disturbance because there is a power gone in the middle. Okay, that first part is lecture 8A that you can see, and continue with the same lecture B, 8B. Okay, almost just 10-15 minutes is needed to complete the chapter. Please, so please cooperate. Right. See, students, as I was discussing with you, oxidizing properties of potassium permanganate in acidic medium. In acidic medium, potassium permanganate, say permanganate ion is get reduced to manganese ion by accepting gaining 8 electrons in the acidic medium. Okay, same he has used. Ferrous to ferric and oxalate to carbon dioxide. See, very, very important for 2 marks in theory. They will ask you this compulsorily. Ferrous to ferric, oxalate to carbon dioxide, and itself to manganese ion. Okay, right. Now, once again, I will continue with the two to three more oxidizing property after iode, ferrous and oxalate. Now, I will continue, students, with the iodide. See, next third one, see iodide to iodine. Uh, The same base, see, MnO4 minus with iodide, I minus, okay, and acidic medium H plus, right? What it gives? First, as usual, Mn2 plus. Oxidized product is I2, remember, and water is common. So once again, 4H2O, 8H plus. This is important. I2, 2I minus it is. 5 electrons. That's why 5 into 2, because 5 electrons are to be added. Therefore, 10I. This is 5I2. Right? And this is as it is. MnO4 minus everything is balanced. MnO4 plus 7 plus 10I minus plus 8H plus gives what? Mn2 plus 5I2 plus 4H2O. That means iodide, potassium iodide is oxidized to violet vapors of what? Violet vapors. Violet vapors of iodine. Okay, that means pale yellow color get changes to fine violet vapors, which are very disagreeable, pungent smell. Okay, right. So try to understand like this. That means in these three only one is guaranteed fixed: ferrous to ferric, oxalate to carbon dioxide, and iodide to iodine. Remember. Okay, for theory. Next for CD purpose, another more. See. Next one what? Nitrite NO2 minus. Nitrite to nitrate NO3 minus. Let us see. See this MnO4 minus with nitrite NO2 minus in acidic medium. Okay, gets converts into Mn2 plus NO3 minus and H2O. Right? Nitrite. Plus 4 to here plus 5, because here plus 4, right, minus 4 that side 1, okay, plus 3 to here nitrate 6 means 5 plus 3 to plus 5 for 2 electrons are gone, therefore remember 5 NO2 5 NO3, since 2 electron it is, right, so 3s2o 6h plus. Definitely, this is the right balanced equation for nitrite to nitrate. See, 5 to the 10, okay, and here 5 3 is a 15, 15 plus 2 18, and here already. So 2 MnO4, 2 Mn2. This is the right answer. Okay, like this you have to balance the equations. This is for what? Nitrite to nitrate. Like this, students, if you come for next oxidation, because keeping this as a main base, this is important, that's why I'm not wiping this. Okay, next if convert sulfite SO3 2 minus 2, sulfate SO4 2 minus, same manner, no change. MnO4 minus you write, okay, sulfite you write, SO4 through 3 minus, okay, acidic medium you write H plus, right. First you write Mn2 plus, reduced product, then oxidized product SO4 2 minus, then as it is water. So once again, see, sulfide to sulfate. What is the oxidation state of sulfur here? Plus 4. Here, plus 6. Once again, 2. So 5SO3, 2 minus 5SO4. Why? Because 5 electrons. 2Mn2 plus 2MnO4. Once again, 18. 5 3 the 15 plus 8, 23. Here also 5 for the 20. So 3H2O, water, 6H plus. Very simple. Like this, you can easily balance. Nitrite to nitrate, sulfide to sulfate, right? Plus 4 to plus 6 here, plus 3 to plus 5. That's why balancing electrons, reduction is gain of electrons. So try to remember like this, students. So these are the important oxidizing reactions of a water, that is, so iodine we have seen, iron oxalate. Okay, now lastly hydrogen sulfide is remaining. That also I will complete. Okay, hydrogen sulfide 6 H2S2, yes, that is sulfur. Finally, with hydrogen sulfide to sulfur, once again see MnO4 minus plus H2S plus H plus in acidic medium. Okay, Mn2 plus plus reduced product, yeah, oxidized product, yes, and this is H2. Here also 5H2S, okay, therefore 5S. Note down 2Mn, 2MnO4. Okay, right. Now see already how many are there? 10. Here therefore 3S2, right? Because sorry, 8S2. Already 5 are there. Therefore what is remaining? 6 H. Over. Right? This is the balance equation for what? Minus 2 is oxidized to 0. Right? Therefore, this is the balance equation for oxidation of potassium permanganate to sulfur, elemental sulfur, elemental sulfur. Very important for 1 mark, so many times asked in the theory. These are the 5 oxidizing properties of what? Potassium permanganate. Where? In acidic medium. In acidic medium, I am repeating, students. This base you have to remember. Okay, today there was a very much problem in technical problem in the videos. Okay, so please try to remember. Please try to remember where in the acidic medium. In the acidic medium. If you make this as base, you can easily balance the equations. But practice is needed. Compulsory, you have to write 2 to 3 times today itself. Okay. Right. Hence, that means potassium permanganate oxidizes ferrous sulfate to ferric sulfate, ferrous ion to ferric ions. Next, iodide to iodine and oxalate to carbon dioxide. Like this, nitrite to nitrate and sulfide to sulfate. Okay, in CET, no need of this balancing is needed. Just have to remember oxidized product. Okay, but theory you have to write this compulsory with the explanation. Right? Okay. Now coming to lastly, see this is in what? Acidic medium. But potassium permanganate also act as oxidizing agent in the basic and slightly neutral medium. That's why in neutral and faintly alkaline medium. Alkaline means it is a basic medium. What are the products? Slightly product differs. See here. See MnO2. Okay, MnO2 plus I minus plus S2O. See here, first reaction what I written here in neutral medium 2MnO4 minus, sorry, this is 2MnO4 minus reacts with iodide, oxidizes iodide to what? Plus 4 plus 7 is oxidized to plus 4. Oxidizes iodide to iodine, iodate IO3 minus. See, difference is very important. Just try to remember. In acidic medium, potassium permanganate oxidizes iodide to iodine vapors, but in alkaline, slightly alkaline medium, that is in neutral medium, it is oxidized to iodate itself reduced to manganese oxide, manganese dioxide. That's why change plus 7 to plus 4, 3 units. right? This is a chain. You have to remember, right? I am repeating MnO4 to Mn2 plus where acidic, but here MnO4 minus to MnO2. And also changes iodide to IO3 minus iodate, but not iodine vapors. Very, very important point to be noted for need. So many times asked. Next, same potassium permanganate with sulfite in neutral medium, right? See, this is a thiosulfate, S2O3 to sulfate. And once again here, see MnO2 as it is, plus 4, plus 7. And hydroxyl ionizer reduced product. And lastly, MnO4 even it can change its sulfide. Now this is thiosulfate in neutral medium. Okay, same is written here. MnO2 6. This is repeated. Sorry, extremely sorry, students. Just to you have to remember. More than enough. What are those? In neutral medium or slightly alkaline medium, potassium permanganate oxidizes iodide to iodate itself reduced to manganese dioxide. That's the chain. Whereas potassium permanganate oxidizes thiosulfate to sulfate, reduces itself to manganese oxide. Remember, MnO4 minus to Mn2 plus, remember, in acidic medium. In acidic medium. I am repeating, students. But MnO4 minus plus 7 to what? MnO2 plus 4 in basic or neutral. Okay, remember, neutral medium. This difference you have to write. Remember, here 5 electrons, here 3 electrons. Got it? So this is the important information for oxidation reactions. And lastly, 2MnO4 even further reduces Mn2 plus the same to what? Same MnO2 only. MnO2 only. 3MnO2 plus 2OH minus. Very simple. 2OH minus. Right? That means because here 3 electrons are no 3Mn2 plus 5MnO2 because 10 it is 10 plus 2 12, okay, 4 2H2O, sorry, 2H2O. But now it is balanced. 5MnO2 plus not hydroxyl, sorry students, it is 2H plus because see in a neutral medium it will give out H plus this time. This is a very important. That's why permanganate also oxidizes manganese to manganic oxide plus 4 itself will not be because it's in a neutral medium, not in acidic medium. Like this, will ask you for need, very important, first and second. So these are the other oxidizing properties of what? Potassium permanganate. Other oxidizing properties of potassium permanganate where in basic or alkaline we can tell, or in neutral medium. But in acidic medium, fix this is. In acidic medium, this is fixed. Okay, please try to remember these bases. This one that according given you here shortcut, and this is for basic medium, right? When it gain 3 electrons, MnO2 plus 3H2O means 6H plus you have to add here. This is not in acidic medium, that's why it is in basic medium. Right, that's about completion of both also the oxidizing properties of potassium permanganate. And remember, in titration, when you potassium permanganate is titrated with dilute sulfuric acid, right, with FAS, the results are satisfactory because we will get colorless to pale pink. Instead of H2SO4, we use HCl. It is not satisfactory. Why? Because potassium permanganate is a strong oxidizing agent. It oxidizes HCl to chlorine gas, right? That's why unsatisfactory. Very important for CET. So many times In a competitive examination, JEE main examination, this question was asked. Right? Now finally, lastly, structure of manganate and permanganate. Manganate and permanganate, what's the difference? Permanganate, see, it is a MnO4. 1, 2, 3, 4. Okay? Oxygen, oxygen, oxygen. Right? Okay. This is for what? MnO4 minus. But MnO4 2 minus 1, 2, 3, 4. Right? O, O, and this is O. Right? Here also O. This is a structure for what? Manganate, and this is permanganate. This is what? Permanganate. MnO4 minus. This is manganate. Manganate you can tell. Okay, manganate. That is MnO4 2 minus. If you don't write here, they can carry charges here, minus, negative, negative. And here, any one carbon atom. Other than they are just the handwise like this. Double bonded carbon atoms. Okay? And manganese here only, let's see, get negative charge. Like this here also. 1, 2, 3. No, 2 double bonded atoms. Double bonded character. Remaining minus, minus. But both magnesium are what? Manganese here also sp3 hybridized, sp3 hybridized. Both the units are having what? Tetrahedral structure units, and they are sp3 hybridized. And lastly, uses this potassium permanganate. Potassium permanganate is what? Potassium permanganate is used as once again powerful oxidizing agent, primary standard solution. Okay, and also this. Potassium permanganate, what are the uses? Applications are so simple. Okay, that is for preparation of organic compound, and that especially mainly it is used as primary standard solution. Okay, as an important laboratory agent in the form of primary standard solution, and production of K2MnO4. These are the some important applications. Mainly as an analytical reagent it is used. Okay, right. So that's about the completion of C students D block elements with physical properties in detail we have discussed. Okay, and all unique characters of transition metals along with the all study we have discussed, and the two compounds. What are those? Potassium permanganate, as well as potassium dichromate. I'll repeat, potassium dichromate and potassium permanganate with their preparation, physical properties, chemical properties, structure uses. Preparation, physical properties, chemical properties, structures, and uses. Okay, one is fixed. Either preparation of potassium dichromate from chromite ore or preparation of potassium permanganate from the pyrolusite ore. 3 marks, one theory question fixed. And one oxidizing property, they may ask you any one. Either ferrous to ferric or iodide to iodine, especially in acidic media. Okay, and I told you wherever necessary need points I have to highlight. Okay, so we'll stop here today the online classes. That will be the end of D block elements. In your next live, that is in offline classes, when you come to a college on the Monday, we'll start with a fresh chapter, that is solutions. Okay, solution in one track, and another one haloalkanes and haloarenes in the another track. So please students, while coming, you can bring up these both the notes, because we don't waste any time now. Okay, already so many time is wasted, right? So while coming to Monday, you can please bring up solutions, haloalkanes and haloarenes. So thank you. Have a nice day. Last